Hello, in our last two lessons, we have introduced two vectors. They are geometric vectors, that is no xy coordinates system, and also algebraic vectors. Algebraic vectors, we put the vectors, the tail at the origin and the height to where the vector pointing. So vectors, we have two things we need to have for vectors. One is magnitude, another one is direction. And also we have in the second lesson we have done the vectors in 2 dimensions and 3 dimensions. In the 2 dimensions, 3 dimensions, we have component form. This is x coordinate, y coordinate, and also we have the unit vectors form. So I and j, they are the unit vectors on the x-axis and the y-axis. So I is just 1, 0 unit. The size is 1. And j is just 0, 1. So it's just unit vectors on the y-axis and on the x-axis. So in unit vectors, we just put the x-coordinate at front of the unit vectors I, x direction at front, and y coordinate at the y unit vectors j at the front. And the magnitude is just a squared plus b squared equals c squared. The c is your magnitude. So it's Pythagorean theorem. And for the 3 dimensions, it's same thing. It's x coordinate, y coordinate, z coordinate for the component form. And the unit vectors is ijk, the k. So now it will be in 3 dimensions. So I is x direction is 1, other 2 directions is 0, 0. J, the unit vector at the y direction is on the y direction is 1, others is 0, and the z, k is the z direction. So only the z direction is 1, other 2 directions is 0. So we call them the unit vectors, standard unit vectors on x, y, z axis. And magnitude is just a squared plus b squared plus c squared. You can think that you have to apply the Pythagorean theorem twice. This is one right angle triangle. Then after that, this Pythagorean hypotenuse formed with c, another right angle triangle. So this squared plus this squared give you the distance from O to P. So magnitude is just the distance from the tail to height. So this is what we have covered, and in this lesson we are going to do operations on algebraic vectors. Operation means adding, subtracting, and multiplying. We are going to do it in our next 2 lessons. Okay, we are focusing on adding, subtracting, and multiplying. We only do the scalar. So a number times, not vectors times vectors. Okay, then we are going to see example 1. Adding 2 vectors using component form, using this form. So this is x, this is y, this is x, this is y. Finding the first one is just a sum of these 2. And we are going to just do the x component, y component, adding, subtracting separately, but we are not going to write x component, y component. We just write the vectors in component form. Then we are going to add x component correspondingly. So it's 5 plus -2. Then another one will be the y direction is -7 with 3. Y component add y component. Then just you will see if you understand the concept. the calculation is not hard. It's just adding, subtracting integers. So 5 plus -2, larger number is 5, so the final answer will be positive. Then different sign, subtract. So 5 minus 2 is 3, so positive 3. This one, larger number is negative, so final answer is negative. Opposite, subtract. The difference of 7 and 3 is 4, so -4. Then this is done. And question B. So W equals 6U minus 4V. We are going to sub in the component vector. So U is 5, -7, minus 4 times -2 and 3. So we are going to expand, treat it as the same as a bracket, so just times it. 6 times each component in the bracket, so we have 30, -42, then minus, just 4 times -2 is -8, 4 times 3 is 12, then continue, do the adding, subtracting correspondingly, so x direction to x direction, y direction with y direction. And be careful, this time is 30 minus -8. -42 minus 12. Then do the integer adding, subtracting. We have 38, negative, double sign is negative times negative, positive. So 30 plus 8 is 38. -42 minus 12, larger number is negative, so final answer is negative. Negative, we just add the numbers if they add with the same sign. So 42, 12 is 54. Then it's done. So this is adding, subtracting the vectors in component form. Then we are going to continue to do the unit vector form. Oh, this is not unit vector form, it just continue, okay? So 2 dimensions is component form again, so it's just the reason why I put this one here is just one is plus, one is minus to show the difference. And also you need to graph it, okay? So A plus B. It's just add the x direction together, add the y direction together. We could just use 1, 3 plus 4, -2. Then x plus x is 5. Y plus y is 1. It's done. And A minus B is 1, 3 minus 4, -2. So 1 minus 4 is -3. 3 minus -2 is 5. Then it's done. So this is a component vectors, and if you want to use a unit vectors form, you could change it to I and J, okay? So now we want to graph it. So A is 1, 3. This is A, 1, 3. And B is 4, -2. So 1, 2, 3, 4, 1, 2. This is B. It's 4, -2. So we want to add them together. It's just put the tail height, copy it here. So 4, -2. So this is our B. Then the final one will be from the tail to the last height. This is our sum, A plus B. And we are going to draw another graph again, sketch it. So for the minus, so this is 1, 2, 3, 1. This is our A. B is 1, 2, 3, 4, 1, 2. And this time it asks you minus B. So minus B we know is just opposite direction. So negative B will be this direction. And when we A plus B, we put the tail to the height of the A, then draw exactly same. Negative B here. Then from height, the tail to the last height, this is our A minus B. And you will see it is -3 and +5. Okay, so this is if we want to draw it, how we draw it, we draw A plus flip the B to another direction, that is minus B. And when we add them, we put the tail height, so tail height, then put another tail. This is our first vector, then tail height again. This is our second vector, then the final is just a first tail to the last height. This is our final one. Okay, so this is adding, subtracting the vectors, and we are going to practice more in 3 dimensions. So this is example 3. The R3 is just means in 3 dimensions. So this is X direction, Y direction, Z direction, and determine each of the following. And this time is OA is just a magnitude. So we know so this is A, OA, it's just magnitude and it's square root of the x, y, z direction. So A, B, C is just A squared plus B squared plus C squared. Then we sub in 7 squared plus -11 squared plus 13 squared. We have square root. Use your calculator, 339. We could roughly round it to 1 decimal places, 18.4. And question B is OB. So this is just a magnitude for the vector OB. Okay, so A, B, C again. Or you could use X, Y, Z. A squared plus B squared plus C squared, then sub in given information. 4 squared plus -7 squared plus 25 squared. Then we have square root 690, then round it. And how many decimal places you are going to keep? Just see what the question is asking you to keep. Otherwise, if the given information is no decimals, actually you could just round it to no decimal places, but I just keep one more than the given information. Okay, so question C, A, B. So this is a tricky question. We didn't see such question before. So we are going to just sketch it and see what vector AB represent. So 3 dimension, we just ignore the 3 dimension, just randomly sketch it. So this is okay, this is X, Y, Z, and 7 this direction, left and up. So it's kind of this direction, left and up. So this is your A. And B is 4, -7, and up 25. So this is B. And from A to B is this direction. So we want to know how we can find from A to B. This is OA. This is vector OA. This is vector OB. So AB is kind of, we have from A to B, how we can draw this one is equals OB minus OA. And how we can get that one there, we could redraw it. So this is a tail to hide. So this is and you could see from here, this is OB is tail to hide for OA and AB. So from this graph, you will see OB equals tail height, OA plus AB. Then we isolate AB. It means we move the OA to other side. So hope you can see it. This is a sum. This is OB. A sum of OA plus AB. So AB equals OA minus OB minus OA. Then we know the adding subtracting already. We just OB is 4, -7, 25. Subtract OA is just 7, -11, 13. Then x direction subtract 4 minus 7 is -3. Then y direction subtract -7 minus -11 is +11 is 4. Then 25 minus 13 is 12. Then it's done. So this is AB. And how to find AB is just OB minus OA. The second letter minus the first letter. Then the question D is find the magnitude of the AB. So for magnitude, everything is same, and this time ABC changed. X, Y, Z. So magnitude for 3 dimension is just A squared plus B squared plus C squared. Then we sub in the given information. -3 squared plus 4 squared plus 12 squared equals square root. Get your calculator is 169. Round it's a perfect square number equals 13. That is done. And you may wonder, do I have to sketch these vectors diagram each time in order to find the vectors AB or something? You don't have to. It can't. You have the pattern for that. So if you have CD, for example, always the second letter minus the vector for the first letter. So OD minus OC equals CD. Why it works? So we can draw it. This is OC. This is OD. And this is from C to D. And you will find out tail to hide. This one is always the sum of these two. So OD equals OC plus CD. You can think CC, the same number, cancel out. You only have OD left. Okay? And you will find out CD is always equals the second letter OD minus first letter OC. Okay? It's always true. and this one cancel out is always true. So for example, if we have OA plus AB plus BC plus CD, all the same letters, it's kind of you can cancel out, then you have only the first and the last letter left. So this works. It's just like tail hide, then tail hide, tail tail cancel out, tail hide, tail hide. So the first tail, last hide give you the sum. Okay. So this is example 3. Now we are going to see our last example, example 4. So if A, B are opposite vertices of a parallelogram OAPB. O is at origin. It asks you to find the coordinate of the P. So this is kind of like the applications. We could randomly sketch a parallelogram. So we follow the order OAPB. Okay, we have OA, we have OB, we want to find the point P. So, and you can see this is A, this is B, and this side equals to OA. So this is A again. You will find out tail height, and from tail to height, this OP is just a sum of the A plus B. So we are going to have OP equals OA plus OB. It works because it's a parallelogram. And this is also the method, another method to draw to find the sum. If we want to graph it, tail height, you just draw a parallelogram, then the diagonal is the sum of the OAOB. So now we put the numbers in. So 1, -5, 2, plus -3, 4, 4. Then XX adding. So make sure YY component 2, 4, 6, then it's done. So therefore, the coordinate of the point P is -2, -1, and 6. So this all the questions we have used the component vectors, and now I want to show you method 2 to use the unit vectors to solve this problem, and all the above questions you could use this unit vectors method to solve it. So unit vectors method OP equals, this time we write OA not in the component vector form, not component form. We write it as unit vector form. Unit vector form, it means 1, then x direction is a unit vector in x direction I. Then y is unit vector in y direction is j. Then z is 2k. This is for our first OA. Then for OB, it's just -3 x direction plus 4 y direction j, and z direction 4k. Then we do the same thing, I direction like the class-like terms. So for this one, you can think it's just I direction the like terms. So 1 minus 3 is -2, and the j direction -5 plus 4 is -1. K direction, collect the like terms, is 6. Then you will see -2, -1, 6. They are same, okay? So I don't mind if the question didn't say component vector form, component form to solve the question, or unit vector form to solve the question. You can pick either of them, which one you feel more comfortable, okay? And this is all for today's lesson. What we have done is we reviewed component form is xy coordinates only in bracket, and the unit vector is in the ij or k form, and the magnitude is a squared plus b squared, Pythagorean theorem. And for 3 dimension is a squared plus b squared plus c squared square root. And ijk is just I is only 1, not 0. Its unit vector is 1. And the j is y coordinate, not 0, is 1. And k is just the z direction. The z coordinate is 1. Then for the adding, it's just corresponding x component add together, y component add together. If we have a number at front, we just like expanding the binomials or trinomials, just times it to each component in the bracket, then do the adding, subtracting accordingly. And for adding, subtracting, you will see is adding is just tail height, tail height. And if subtract, we just flip that vector to opposite direction. Then we do the adding a plus -b to find the sum. Then we continue to find the magnitude for the 3-dimension vectors. And also we find if we have a vector AB, you could write the second letter OB minus the first letter OA to find the adding, subtracting by adding, subtracting 2 vectors to find the final vectors. And the interesting thing is if you have a chain of vectors, as long as the letters same, we can cancel them out. We only have the first letter and the last letter left, tail to the last height. And if we have 2 different letters, we could use a second letter with O minus the first letter with C. The reason is we rearrange it, so OC plus CD, CC cancel out, we have OD left. Then the last question is if we have a figure here, we could use a parallel, same direction, then we could move it to the height here. Then tail height is from tail to height is a sum. So then we could use adding, subtracting vectors to find the new vectors. And I also showed you could use a component form or you could use a unit vectors form. Unit vectors form is just x coordinate followed with a unit vector in x direction, which is I, y direction j, k direction is k, the unit vectors. Then just like the collect like terms, I together, j together, k together. Then that is all for today's lesson. Thanks for watching.